Hello everyone, and today we've got a video all about hypothesis testing, and it's a real useful one because it's one of those questions where it says that the critical region should be as close as possible to a certain amount, which is kind of like a little bit of a little alternative spin on the whole thing. And we're going to be finding the critical region. So let's have a look at the question. It says past information shows that 25% of adults in a large population have a particular allergy. 𝗏𝗏 believes that the proportion that has the allergy differs from 25%. He takes a random sample of 50 adults from the population. 𝗏𝗏 carries out a test of the null hypothesis 𝗏𝗏𝗃0 equals 0.25 at a 5% level of significance. So part A, it says write down the alternative hypothesis. So the first thing to note is that we've got a two-tailed test. So we have our null hypothesis is that the probability is 0.25. And our alternative hypothesis is going to be that it is not equal to 0.25, okay, because we have a two-tailed test. Note that that means that because we have overall a 5% level of significance, we're going to be considering 2.5% at each end of the tail. So remember, you have to split the significance level in half when you are doing a two-tailed test. So that's part A, it is not equal to 0.25. Part B, find the critical region for this test. You should state the probability associated with each tail, and it should be as close as possible to 2.5. Now, let's have a think about this. So first of all, let's write out what the probability distribution is going to be like. So we have got that X, the probability of somebody having the allergy, is going to be binomially distributed because either they have the allergy or they don't, and that is independent of each other. And there's a fixed number of trials, which is 50 adults. So we have a binomial with 50, and our P is 0.25. Okay, there we go. Now, it's also useful, I think, to work out the expected value. Remember, in the binomial, the expected value is n times p. So in this case, the expected value is going to be 50 times by 0.25, and 50 times 0.25 is 12.5. So the expected value is 12.5. That just helps us to know where we use the less than and greater than symbols. So let's go over to the left-hand side of the distribution. We now know that to be over at the left-hand side of the distribution, we need to be less than 12.5. So let's just try, let's imagine we tried a probability of X is less than or equal to 10, just to start off with, just randomly. Okay, now when we calculate this in our calculator, remember we need to be using Binomial CD. Now there are so many different calculators that students are using these days. Some people are using this one being phased out. Some people are using this new one. Some people are using the CG50. Some people are using CG100. So there's lots of variants of calculators, but just remember Binomial CD, okay, is what we're looking at here. So when we work out the probability of X is less than 10, you should get 0.2622 for that one. Clearly, that's way over what we need. So let's go down and try 7. Probability of X is less than or equal to 7. That turns out to be 0.045. Okay, so we're getting closer into the right ballpark now. Still above though, X is less than or equal to 6. So this one, we work this one out. This is 0.0194. Now, under normal circumstances, we would just go straight ahead and say, okay, the critical region must start at 6, okay? However, we've got to be careful here because what this question is saying is which one of these is closest to the 2.5, which is 0.025. So what we've got is 0.045, and then we've got 0.0194. Now the gap between this one and the 0.25 is the smallest, okay? So in other words, this one is closer than this one. And this, remember, is our probability of X is less than or equal to 6. And this is our probability of X is less than or equal to 7. So we're going to go with that one, okay? So On the left-hand tail here, the critical region is that x is less than or equal to 6. Okay, that's the critical region on the left-hand side of the distribution. Let's do the same over now at the right-hand side of the distribution. Again, I'm just going to randomly pick probability. Let's do x is greater. Now we're greater than because we're over at the other end of the distribution. Now again, depending on what calculator you're using, you might have to work out probability of 1 minus x is less than or equal to 19. Okay. However, if you have the CG50 or the CG100, you can just do it directly by just selecting the right-hand tail. But when we work that out, that turns out to be 0.0139. So we're in the critical region there. Let's have a look and see what happens. Let's go and see if we were at 19 then. So let's go back a bit. Greater than or equal to 19, which is going to be 1 take away probability of x is less than or equal to 18. When we work that out, that gives us 0.0287. Okay, so let's consider these two candidates now. Okay, so we've got here 0.13139. We've got our 0.025. We've got our 0.0287. Okay, so this one is bigger than the 2.5, but you can see it's really close to 0.025. It's just a little bit over. So in this case, this one is closer to the critical value. So that's what we're going to go with. Okay, now this is interesting, and this is where this question, or this approach, differs from the traditional approach. Because notice we've accepted that our critical region is starting at 19, even though this value is bigger than the 2.5. Ordinarily, we only say that we're in the critical region if this number is less than. Okay, so that's what's different about when they ask you to compare and they ask you to write down which is the closest. Really important point that. If this was a normal question and this particular wording here wasn't there, which should be as close as possible to the 2.5, if they hadn't have said that, then the value, the critical region, would have started here at 20, because this is the first value that is less than the 0.025, okay? So if the wording of the question hadn't said must be as close as possible, we would have gone with this value, okay? However, because it does, then we compare both of them, and even though this value is bigger than the 2.5, it's still closer to the 2.5, so we're going to say that that's where the critical region starts, okay? So over here at our other end of the distribution, we have the critical region 2 is that where x is greater than or equal to 19. And that is part B done for 4 marks, okay? Really nice little, it's good. I think it's good to have a look at this exam question in order to be able to identify that. Okay, now, again, this is another really useful thing they're saying in part C now. So part C, and I like the wording of this. So it says, state the actual probability of incorrectly rejecting HO for this hypothesis, okay? Now, when they ask you for the actual probability, what you've got to do, when you've calculated two different probabilities, the actual probability is just the probability from both of your critical regions added together, okay? So the two ones that we found were 0.0194, 0.0287. So we're going to add those two together, okay? So when they ask you what is the actual probability of incorrectly rejecting HO, we add those two values together, okay? So that is going to be, to part C, our answer is 0.0194, and we're going to add to it 0.0287, which is going to give us 0.048. Okay, that's what you do for that one. And then finally, it says Ryland now finds that 10 of the adults in the sample have the allergy. State the conclusion. Okay, so 10, are we in the critical region? Because the critical region is x is less than or equal to 6 or greater than 19. So we're not in the critical region, okay? So we're going to say that there is insufficient evidence to reject HO. Insufficient evidence to reject HO. okay? And that means that, you know, there's not enough evidence to suggest that the proportion of adults in the population that have the allergy differs from 25%, okay? So I'll just say that again. There is insufficient evidence to reject HO. And what we could say is, we could say that there's not enough evidence to support the belief. Let's write that down. Not enough evidence to support the belief. Support the belief that the proportion differs from 25%. Okay. Proportion differs from 25%. Do apologize for my horrendous handwriting there. So insufficient evidence to reject HO, not enough evidence to support that the proportion differs from 25%. Okay. Yeah, I once taught a student a couple of years ago who said that, because, you know, sometimes people say, oh, we're going to accept HO. And they said it's not good to say accept something because statisticians don't like to accept anything, which I thought was kind of nice. I can imagine that. Statisticians don't like to accept anything. So try and avoid saying we're going to accept HO. So instead of saying we're going to accept HO, it's better to say there is insufficient evidence to reject HO. Perfect. I hope you found that useful, and I will see you all in the next video.